Hi everyone. Today, for one-step examples to show the relationship between pH and hydronium ions and the relationship between pOH and hydroxide ions. First example, calculate the hydronium ion concentration if the pH is equal to 4.42. The hydronium ion concentration is equal to 10 to the power of the negative pH. Just that one variable, and we have it. So we substitute into the equation. 10 to the power of negative 4.42. I'm going to type that into my calculator. 10 to the power of negative 4.42. Again, 3.8019 times 10 to the power of negative 5. That's the raw answer. We need to go back and think about the significant digits and the units. 4.42 at first glance feels like it has 3 significant digits. However, the rules for pH and pOH are that only the decimal places are significant. And this just has the 2 decimal places, 2 significant digits, which must be reflected in our answer. I round it off to 3.8 times 10 to the power of negative 5. Finally, this was a concentration that we solved for, and that's moles per liter. A second example, calculate the hydroxide ion concentration if the pOH is equal to 10.396. The hydroxide ion concentration is equal to 10 to the power of the negative pOH. Very similar to the first question, only all the analogous chemicals. We're going to substitute 10 to the power of negative 10.396. And I do that calculation. 10 to the power of negative 10.396. We get 4.017908, etc., times 10 to the power of negative 11. Once more, we need to go back to reflect over the significant digits. 10.396 has 3 decimal places, 3 significant digits, which we want to reflect in our final answer. Here, 4.02 times 10 to the power of negative 11. And once more, this was a concentration that we solved for, moles per liter. The third question says, calculate the pH if the hydronium ion concentration is equal to 7.5 times 10 to the power of negative 4 moles per liter. This time, the pH is equal to the negative log of the hydronium ion concentration. We have the hydronium ion concentration. We just want to substitute that into our equation, which is equal to the negative log of this value, 7.5 times 10 to the power of negative 4 moles per liter. I need to type that into my calculator. Negative log 7.5 negative 4. I have this expectation that the answer should work out somewhere between 1 and 14. If for some reason I don't get that, maybe I missed the negative or I made a mistake entering it into my calculator. Here, we end up with the raw answer, 3.124938737. We need to go back to look at the significant digits in the question. This is a concentration, 7.5 times 10 to the power of negative 4 moles per liter. And the rules for significant digits for concentration are what we've been accustomed to now through Chem 20 and so far this term. 7.5 times 10 to the power of negative 4 has 2 significant digits. That means my pH answer must also have 2 significant digits. However, it's the decimal places that are significant. So I need to have 2 decimal places in my answer, which is 3.12. pH also does not have units, so we're finished that question. Finally, calculate the pOH if the hydroxide ion concentration is equal to 4.82 times 10 to the power of negative 9 moles per liter. Here, the pOH is equal to the negative log of the hydroxide ion concentration. I'm going to substitute the value into the equation, which is equal to the negative log of 4.82 times 10 to the power of negative 9 moles per liter. I'm going to type that into my calculator. Again, I have this expectation that the answer should work out between 1 and 14. If I don't get that, maybe I missed a negative or I entered it incorrectly. It's the negative log of 4.82 times 10 to the power of negative 9. Here we get 8.31695292. This raw answer. Reflecting over the significant digits, the concentration given in the question had 3 significant digits. So we want my pOH to also have 3 significant digits. Again, pOH, just the decimal places are significant. This is going to become 8.317. And like pH, pOH does not have units. And I hope that helps.